I'm on page 287, and we're going to be looking at number 5. The graph of the parent linear function f of x equals x is shown in black. Everything's in black and white, so it's kind of hard to tell. But they're talking about this right here. Okay. This is your no-frills parent function, your simplest linear function. Slope is 1, y-intercept is 0. So it goes through the origin and has a slope of 1. It's right there. Write the function that represents this function with the indicated parameter changes. All right. M increases, B is unchanged. So the slope gets steeper, but the y-intercept is stays the same. And that's going to be g of x, which is this one right here. So it's a steeper slope, but the same y-intercept. M is decreased, so it's a flatter slope, closer to horizontal. B is unchanged, so it still goes through the origin. That's going to be this one right here. And that's m of x. Okay, so the slope is unchanged this time, but the y-intercept is increased. So basically we pick up the original line and move it up, okay? It's just shifted upward. So that's going to be this one right here. And that's h of x. And then slope is unchanged, but the y-intercept is decreased. So you take the parent function and you just shift the whole thing down. And that one is right here. N of x. All right, number 6, for each linear function graphed on the coordinate grid, state the value of m, in other words, the slope, and the value of b, or the y-intercept. All right, so f of x is this line right here. It appears to go through 0, 2, so the y-intercept is 2. And that's got a negative slope of down 2 and over 4, so that's a negative 1/2. G of x is next, and that's this line. It appears to be going through a y-intercept of negative 3, because remember the grid lines are going by 2. And it appears to have a slope of up 1 and over 4, maybe? Or up 1 and over 3, let me see. Yeah, up 1 and over 3. So 1/3 is the slope, and y-intercept is negative 3. And then finally we have h of x, which is this line. It goes through the origin, so the y-intercept is 0. And I'm going up 4 and over 2, so that's a slope of 2. All right, we're going to move on, and we're going to look at 8 and 10. And it says, describe the transformations on the graph of the parent function f of x equals x that results in the graph g of x. Well, basically what they're asking is, what is happening when you go from your function, your y value equaling just plain old x, to your y value equaling 3x? Well, the slope in this case, original slope is 1, and the new slope is 3. So like f of x would look maybe something like this. G of x is going to be steeper. Okay? So the slope is steeper by a factor of 3. I'm going to write that over here. All right. So just to clean this up, remember this one's the original. This one is the steeper one. And I know it's just a sketch. I don't even have grid lines, but all you've done, you haven't changed the y-intercept. You've just made the slope steeper by a factor of 3. In other words, the slope here is 3 times as steep as the slope on the original line. All right, let's look at number 10. G of x is equal to 7x minus 8. All right, f of x is the original. You had a slope of 1 and a y-intercept of 0. G of x, you've actually changed 2 things. Your slope is 7, so the line is much steeper. And the line was shifted down 8 units. Okay. So let me write that for you. All right, that should take us through 10. And the last one we're going to look at is number 12. The instructions say to use the parent function and the description of the transformation to write a new function. So number 12 says transform the graph of f of x equals negative x plus 2 in such a way that it has the same steepness in the opposite direction. Okay, so first of all, no change in y-intercept. Okay. The slope, we want it to be just as steep, but we want it to run the opposite direction. So negative x plus 2 is going to look something like this. Hang on. There we go. All right, negative x plus 2, and this is just a sketch. Okay. If I take that and I flip the slope, I'm going to go from negative 1x to positive 1x. So I'll write a new equation. I'll call it g of x. Okay, it's going to still go through the same y-intercept, but it's going to have the opposite slope. So it's going to run positive, whereas the original one was negative. Okay. Okay, I really don't feel like my sketch was the greatest job in the world. So this is f of x equals negative x plus 2. And it just simply says transform it in such a way that it has the same steepness, but in the opposite direction. So same steepness, I still want a line that has a slope that has the absolute value of 1, because like this has a slope of 1, but it's negative, over 1 down 1. But I want a new line. Remember, it's going to go through the same y-intercept. But the slope is opposite, has the opposite value. That should be a little bit better picture. Okay. So what you've done on this transformation is you have changed the sign of the slope. So it did run down, now it runs up.